All right, I'm trying to make this a pretty quick video. We only have 7 and 8 to do. I've got 7 set up. What's happening is we have an observer up here on a tower, and they're looking down at a kayak on one side of their observation tower, and what's the other one? Sailboat on the other. So here's a sailboat at 76 degrees and a kayak on the other. The observation of a lighthouse. We know that the kayak is 124 feet from the base. So kayak, 124 feet. And they can see the observer by looking at an angle of elevation. So the kayaker is looking up at 32 degrees. The person in the sailboat is looking up at 76 degrees. They want to know how far apart are the kayak and the sailboat. So we don't have a whole lot of information on the sailboat. We have the degrees of the elevation, and we have h is an unknown. We also, I can call that x, but we have too many variables. What we can do is, looking at the kayaker, we can say that the tangent ratio of that 32.8 degrees, that is the height of the tower over the adjacent side, the 124 feet. So we can say that the h is 124 times tan of the 32.8. We can find that the height of the tower, just like that, is approximately 79. There we go, 79.91 feet. But we don't want to box that in, right? It says how far apart are the kayak and sailboat. So we can't just stop there. We need to keep going. But now we know that that is 79-ish degrees, or feet. Now we have a full triangle here. So now we can use the other tangent ratio, in this case tangent of 76 degrees, which is now that h over x, which was 79-ish feet over x. So again, if we want to solve for x, we switch spots with the tangent, and 79.91 over tan of 76 degrees. X then becomes, what does x become? Becomes 19.92. So the overall distance is going to be x plus 124. So 124 plus 19 plus 19. The distance is there's our bell, 143.92 feet. There you go. So let me pause for a minute while the announcements, and then I'll get to number 8.